What is a graphic representation? Actually, the graphic representation, it's when we use a graph to analyze or obtain or conclude some information. Usually, the graph is showing us the relation between variables. Let's take a look at this graph. Maybe you don't know many things about graphs, but by examining this graph, what can you tell me? The first thing that you can tell me is this is a distance time graph. We have here the distance on the y-axis and the time on the x-axis. If this is a graph that shows the relation between the two variables, distance and time, this means that we can calculate speed from this graph, and we will know later how. Another thing we can observe from this graph is that the distance doesn't change in some parts of the road. For example, from B to C, the distance remains the same as the time passes, and from D to E, also the distance remains the same, 12 meters or kilometers, as the time passes. If the distance remains the same, this means that the position or the location of the object is not changing and the object is at rest. Another thing we can learn, if we take any point distance and divide it by time by choosing random points here on the graph, you will find that the results are different. If the results are different, this means that this is a graph that represents a non-uniform speed. Okay, the graph that we just saw or we just examined is called the line graph, but this is not the only type of graphs that you can see in the internet or in the mathematical problem. We have many types of graphs. For example, we have something that's called the bar graph, another type that's called histograms, the line plot, dots here, and the circle chart, and sometimes it's called the pie chart. We will focus in our study in this year on the line graph. The line graph has an x-axis and y-axis. Let's take a look at this graph. This is a line graph, and it has a y-axis and x-axis. This graph is representing or showing us the relation between two variables. The two variables here are the months of the year 1993, and on the y-axis the discharge amount. Okay, this is for a certain nuclear station, I think, or electric station. Take a look at this one. This is also a line graph, and we have an x-axis and y-axis. On the x-axis, we have the number of trials of the SAT exam, actually, and on the y-axis, we have the score of the math SAT exam. So these are two examples of the line graph. This is interesting because actually this graph is meant to study the relationship between the number of a certain animal during certain periods of time or certain years, starting from 2017 and end in 2022. But the interesting thing here is that we are studying the number of animals or the wild or the population for three different animals, not only one animal. For example, the bears are represented by the blue line, the dolphins are represented by the orange line, and the whales are represented by the gray lines. We can take a look at this graph and conclude some information. For example, for the population of these three animals in 2017, we will observe that the number of bears was very low, and the highest number of population was for whales, for dolphins, and the whales were in the middle. But as the time passes until we reaches 2022, the scientists predict that the number of bears is going to increase, the number of dolphins is going to decrease dramatically, and the number of dolphins will be less than the bears and much higher than the whales. Or the dolphins, sorry. So we can understand many things by just examining the graph. Okay, we will focus on the graphic representation of speed. Let me remind you that the two factors that affect speed are distance and time. How we are going to put these two factors on a graph? Okay, this is speed equals d over t, the two factors. We will see. This is a graph, and if we want to represent the speed, we will put the distance on the y-axis and we will put the time on the x-axis. Now we will see this example. This table is showing us the distance covered by a certain object during time. This is distance and this is time. And we will see how we are going to put them in a graph, or how we will use them in a graph. This is the graph. So after 5 seconds, the object covered 0.5 meters. So this is the first point. After 7.5 seconds, the object covered 0.6 meters. After 10 seconds, the object covered 0.8, and after 12.5 seconds, the object already covered 1 meter. As you see, this is a straight line. Now let's see if we can know which type of speed do we have. If this is a uniform speed, then distance over time is going to equal the same result each time for each point on this line. For example, if we decided to take this point and divide distance, which is 0.4 divided by time 5, this is going to give 0.08 meter per second. For the second point, divide distance 0.6 by time 7.5, also equals 0.08 meter per second. The third point, 0.8 divided by 10 equals 0.08 meter per second, and 1 distance divided by 12.5 time equals 0.08. So whatever the point that you choose to calculate the speed, which equals distance over time, if you get the same result as in here, 0.08, this means that the speed is considered a uniform speed. Take a look also at this diagram. This is also a distance time diagram. If this is a distance time, this means that we can calculate speed from this graph. Take a look at this. This is the first point. Distance covered 5 meters after 1 second. This is the second point. Distance covered was 10 meters in 2 seconds, 15 meters in 3 seconds, 20 meters in 4 seconds. Again, we have here 4 points. If you decided at any of the 4 points or any other chosen points, if you decided to choose another point, we will get the same result. 20 over 4, 5 meters per second. 15 divided by 3, 5 meters per second. 10 times 2, 5 meters per second, and so on. So we can learn here that if I have a distance time graph and the line here is a straight line like that, it means that we have a uniform speed. Take a look at these two graphs. What's the difference between them? Let's examine each one individually. For this one, this is a graph, a line graph, and it represents the relation between speed and time. If you take a look, you will find that it's represented by a straight line like that, but at each point of this line, as the time passes, we get one speed and one speed only, which is equal 0.08. For example, after 2 seconds, the speed is 0.08. After 7 seconds, the speed is 0.08. After 11 seconds, the speed is 0.08. This means that the speed is constant, the speed is not changing as the time passes. This is similar, this graph, the second one, is similar to the graphs that we saw. It's also a straight line, but this is a relation between distance and time. Although these two are represented by straight line, but the straight lines here are different. For example, this is a straight line that's parallel to the x-axis, but this one is a straight line that's coming from the original point. This point is called the original point. If we try to calculate at any point of these, we will get the same result, which is 0.08. Divide distance by time and you will get 0.08 meter per second. So these two graphs are representing different values, but they give me the same result. The object is moving in a uniform speed, the speed doesn't change, and the speed equals 0.08. Okay, this is a distance time graph. The straight line is telling us that the object is moving with a uniform speed. And to calculate the speed, we need to divide distance over time. 0.08, whatever the point that you choose to calculate speed based on it. This is also a graph that's showing us that the object is moving with a uniform speed. Only we have two different variables. But the result's still the same. The speed equals 0.08. So it doesn't matter the graph that you are given. If you are able to read it in the right way and examine it in the right way, you will reach the right conclusion. Okay, this is a simple example. Examine this graph. Try to identify if the speed is uniform or a non-uniform speed, and see if it's a uniform speed. You will calculate it by using the rule speed equals distance divided by time. If it's a non-uniform speed, then you will use the average speed to calculate the speed. Okay. If I see this graph and I see the relationship is here between, or the relation between two variables, distance and time, the line is a straight line that's coming from the original point, then this is a uniform speed. If this is a uniform speed, then I need to choose 2 points. 1 point for the distance and the time related to it. For example, 20. This is the distance over 2, 10 meters per second. Let's choose another one, 40. This is the distance divided by 4, also 10 meters per second. Another one, 60, distance divided by time 6, 10 meters per second. Another example here, we have this graph. We need to identify also the type of speed. Is it uniform or non-uniform speed? And we also need to calculate the speed. If it's uniform, we will calculate the speed distance over time. If it's non-uniform speed, then we will use the average speed, total distance over 2. Now let's see this example. This is also a graph that represents the relation between distance and time, as you see. And he's asking me to see if this is a uniform speed or not, and to calculate the speed if it's uniform speed and the average speed if it's non-uniform. As we see, we don't have only one line, we see 3 lines here, so we don't have like a one line, straight line that's coming from the original, which is this point. So let's see. If this is the case, then this is a non-uniform speed. In the case of the non-uniform speed, it's total distance over total time. So let's see the distance. From here, from A to B, the object covered 3 meters. So this is 3 meters. Now from B to C, the distance remains the same. This means that the object didn't change. From C to D, from meter number 3 to meter number 7, this is 4 meters. So average speed is total distance, which is 3 meters during this phase plus 0. The body here is at rest from B to C. And from C to D, the object cover 4 meters. And the total time for the whole journey is 9 seconds. So 3 plus 0 plus 4 divided by the total time, which is 9 seconds, equals 0.778 meter per second.